making a homemade thermometer. For the very last step of making a homemade thermometer, you have to give it a scale so that you may read the temperature directly.
Full-time kid with Maya. Hi, Maya here. Today we're going to make our own thermometer. Here's what you'll need: an empty glass bottle, some food coloring, some modeling clay, a clear straw, 1/2 cup of rubbing alcohol, and 1/2 cup of water. Pour your water into the glass bottle. Now pour your rubbing alcohol into the bottle. Add a few drops of food coloring. Now mix it like this. Insert your straw into the bottle. Make sure it doesn't fall through or touch the bottom, just like this. Now squish your modeling clay around the straw. Make sure not to cover the top of the straw. The liquid expands when it's warm and moves up the straw. The liquid contracts when it's cold and moves down the straw. Put your thermometer in the sun if you want to see it in action. Let's go check it out. Whoa, that's cool! Science is awesome. Thanks for watching. Pour your water into the glass bottle. Glass bottle.
One more time. Ready?
According to the video, alcohol was mixed with water to prepare the measuring solution. The reason is that alcohol can improve the sensitivity of the thermometer because alcohol expands more than water does. 1.3. Calibrating a thermometer on the Celsius scale. For the very last step to make a thermometer, you have to calibrate the thermometer. You have to give it a scale. An unmarked thermometer should be calibrated so that it has a scale and you may read the temperature from the scale. And now let's see how we may calibrate an unmarked thermometer on the Celsius scale. Put an unmarked thermometer in a beaker of pure melting ice. Make sure the bulb of the thermometer does not touch the bottom of the beaker. Mark the liquid level of the thermometer after it becomes steady. Repeat the steps with the thermometer in a beaker of pure boiling water. Divide the lengths between the two markings into 10 equal divisions. Each division represents 10 degrees Celsius. Use the marked thermometer to measure the temperature of tap water. What is the reading? From the video, you can see we have to put the unmarked thermometer first in ice water mixture and then in boiling water. These two temperatures are important in Celsius scale. These two temperatures are called fixed points. These two temperatures are 0 degrees Celsius and 100 degrees Celsius. Why we choose these two temperatures as fixed points? Because we can reproduce these temperatures very easily. Note that when we mix ice and water together, or when we have steam and water together, we can reproduce the two fixed points for Celsius scale. Ice exists at or below 0 degrees Celsius. Liquid water exists between 0 degrees Celsius and 100 degrees Celsius. And while steam exists only above 100 degrees Celsius. In that case, when you see ice and water together in an ice-water mixture, then the temperature must be 0 degrees Celsius. On the other hand, when you have water and steam together, at that time, it must be 100 degrees Celsius. That is the boiling point of water. So, to calibrate a thermometer, you have to mark the length of the liquid column when it is in ice-water mixture and then in boiling water. And now, what about if I have a length of liquid column of that long? Can you tell me the temperature directly by calculation? On the right hand side of your book, you can see an equation. Equation number 2. The equation may tell you the unknown temperature T. At that time, the length of the liquid column is LT. We have such a formula because from the graph we find that the length of the liquid column increases linearly with temperature, so that it is a straight line. Although it does not pass through the origin, it is a straight line that tells us the length of the liquid column increases linearly with the temperature. So that if we know L0 and L100, then we may substitute that into the formula so that we may calculate the unknown temperature T here for a length of liquid column LT easily. Equation number 2 is not anything special. It comes from the calculation of the slope of the straight line graph. So that from that small triangle, you can see LT minus L0 over T, which is the slope, equals L100 minus L0 over 100. That is equation 3, which may then give you equation 2 above. So you can see equation 2 actually comes from a calculation of slope of a straight line. So in case the length of the liquid does not change linearly with temperature, you cannot use equation 2 or equation 3 anymore. 1.4 Features of liquid in glass thermometer. A thermometer have different parts. This is called bulb, B-U-L-B, bulb. Inside there is mercury. There's also a narrow tube, which is actually vacuum inside with no air. This is the scale, as you may know. When temperature increases, the mercury absorbs energy and then it expands. And then the mercury column becomes longer. And so the temperature reading increases with temperature. The bulb should have thin glass wall so that heat can be conducted to the mercury inside easily, so as to give quick response to temperature change. For the narrow tube or capillary, it should be thin, so to improve sensitivity, as a smaller temperature change may produce a larger change in liquid column if the capillary is thinner. So a thermometer has a larger bulb and thinner bore may produce a larger change in the length of liquid column, and so it becomes a sensitive thermometer. A thin glass wall for the bulb and a conducting liquid such as mercury may improve the response of the thermometer so that the thermometer may give quick response to temperature change. For a clinical thermometer, which is used to measure body temperature, it has a constriction which prevents the liquid from running back to the bulb too quickly, so that it gives time for the nurse to read the body temperature more accurately. 1.5. mercury in glass and alcohol in glass thermometer. You may wonder why we use mercury to make thermometer. Because mercury is the only metal in liquid state at room temperature. All other metals are solid. Mercury is a metal, so it is a good conductor of heat, and it boils at a high temperature of over 300 degrees Celsius. So mercury in glass thermometer may measure temperature as high as 357 degrees Celsius, which is much higher than the boiling point of alcohol. On the other hand, alcohol can measure much lower temperature than mercury in glass thermometer. The another advantage of using mercury in glass thermometer over alcohol in glass thermometer is the quick response to temperature change. However, mercury is poisonous, and mercury in glass thermometer is more expensive than the alcohol one. Alcohol, on the other hand, is not poisonous, and the thermometer is cheaper, but it produces slower response to temperature changes.